Good morning, Ethan. How's it going? Good morning, Justin. Grandmaster to you too, Itamar. Good morning, Diman. Grandmaster. So we have around 2 minutes left. And I guess that's when we'll start it. Good morning, Sarah. So I was looking at a lot of your answers last night and the work you submitted. I think around 2/3 of you submitted it and 1/3 of you didn't. That's totally fine. I know this is really hard. Usually, if we were in like normal school, I feel like I would give you around 2 days to do this. So the fact that you guys had less than 24 hours you basically had 12 hours to do it, right? And it's like not a lot of time. So I'm not gonna penalize those of you who have not turned it in yet, but please have it in by the end of today. Good morning, Yona. But what I did notice is that for those of you who did turn it in, sure. This is, what is this? I think this is my only tea from Uji, which is it is like probably the preeminent region in Japan where green tea is made. So if you think about like red wine, like the most famous and tradition, it's not necessarily the best, but the most famous region where French wine is produced is Burgundy, right? So, and only wines from there and sencha or green tea from Japan, from Uji, is very similar in that it's like extremely traditional. It may not be the best. I mean, that's always subjective, but there is like a distinctive minerally taste to the tea, and that's what it's really known for. Now, if you really like that kind of taste, then sure, you can call Uji tea the best. Do I think it's the best? No. Do I really like it? Yes. 100, oh my gosh. Oh my gosh, 100 subscribers? Okay, so to celebrate 100 subscribers, we are gonna read my favorite poem by T.S. Eliot. Okay, wow, I'm so excited. It is Morning at the Window. Okay, we're not reading Wasteland. Here we go. Okay, They are rattling breakfast plates in basement kitchens, and along the trampled edges of the street I am aware of the damp souls of housemaids sprouting despondently at area gates. The brown waves of fog toss up to me, twisted faces from the bottom of the street, and tear from a passerby with muddy skirts, an aimless smile that hovers in the air and vanishes along the level of the roofs. Is that my favorite poem by T.S. Eliot? No. Do I like it? Yes. That's the theme of today. Things that aren't my favorite, but I still like. Which goes to show you everything is deserving of love and praise as long as it was made with love and care. Okay? Just because it's not your favorite doesn't mean it's not worth studying. I can read it again. I can read another poem. Let's see. Looking for a good one. A 101. Maya, you're the 100th? I'm so proud of you. Most of the other poems are too long, I feel. So I'll read it again. Why not that, huh? Did you know he also wrote a poem called A Cooking Egg, right? Maybe we'll do that on the next cooking live stream, okay? But what we're doing now is Morning at the Window, okay? They are rattling breakfast plates in basement kitchens, and along the trampled edges of the street I am aware of the damp souls of housemaids sprouting despondently at area gates. The brown waves of fog toss up to me, twisted faces from the bottom of the street, and a tear from a passerby with muddy skirts, an aimless smile that hovers in the air and vanishes along the level of the roofs. Happy birthday, Sarah! Wow, I'm so happy for you. How old are you, Sarah? Are you 17? Or are you 16? I never know with your year, it's just some of you are young, some of you are like a whole year younger than each other. It weirds me out. I don't know why that's the case. Oh, but oh my gosh, look at where the time goes. Wow, Sarah, you're a year away from voting. Get pumped, okay? Congratulations. It's your ABBA year. Young and sweet, only 17. Okay, so the time is 10:05. We're starting 5 minutes late because I got distracted by my 100th subscriber celebration. I'm sorry. Okay, I won't let that happen again. So let's get started with number one, right? So I have this 110-volt resistor, battery, so I can write my VIR chart here. So VIR, okay, and sorry, and I have three resistors, 1, 2, 3, and I have my total here. This one is a 15 ohm resistor, this one is a 20 ohm resistor, and then this one is a 30 ohm resistor. So already I can kind of combine these two. So I'll go 1 over 20 plus 1 over 30 equals 1 over R. Okay, and this is going to become 5/60 equals 1/r. So R is 12 ohms. So I know my total, yeah. So these two together make a 12 ohm resistor, which means the total resistance is 27 ohms, right? Because if I have a 12 ohm resistor in series with this one, then together they are 27 ohms, okay? Then I know my total drop is 110, right? And I can look at that one way. What's the total drop in voltage? Well, if I gain 110 here, whatever I lose here and then there, that's 110. Or if I gain 110 here, whatever I lose here and then whatever I lose here has to equal 110. So no matter which loop you choose, the total voltage that you lose is going to be 110, right? And I just did that without even constructing my equivalent circuit loop, right? Which is something you can definitely do. Then my total current, okay? My total current, I gotta go Wolfram Alpha, okay? Why do I sound like this? Because my chin is in my mouth. It is 4.407, right? Let's see if my pen still works. Oh, phew. All right. 4.407, I think, is what we determined. Oh, 4.07. Excellent. Okay. And I know one of my elements actually takes that total current. It's like, where do I see the total current? It's wherever there's still the circuit is concentrated in one branch. So it's this section and this section. So if I had an element here, like a fourth one, then that would also receive the total current. So I know my first resistor receives 4.07 amperes right there. And then I can also calculate the voltage drop from that resistor, right? So I just multiply it by 15. And it's 61.11, right? So I'll just call 61.1, which means if my total voltage is 110, right? Where that means if I lose 61 here, if I go through here, I have to lose 61. If I go through here, I have to lose 110 total. And same thing if I go through there. So all I have to do is 110 minus 61.1, right? And that's 48.8 or 48.9 in our case, right? So I can do that. It's 48.9 volts, and this is 48.9 volts. And then I can very clearly solve for the current, right? So one of them I'm going to divide by 30. And I get 1.62 or 1.63. And the other one I'll divide by 20. Or instead of dividing by 20, I could subtract 1.63 from 4.07, right? But it'll give me the same thing, and it's 2.44 amperes, all right? So these should have been the answer that you have gotten, all right? So if there are any questions so far, please let me know, all right? Cameron, is it also your birthday? Oh my goodness. Let's move on to the second one before Cameron has a chance to answer. Oh my goodness, you guys, are you also 17? Is this also your ABBA year? Oh my goodness. So you and Sarah are twins. Happy birthday, Cameron. Ah, I wish I could pat you on the head and then you would look sheepishly to the right and be embarrassed and secretly wish that I wasn't patting your head and then I would get fired or something. Wow. Happy birthday, Cameron. I hope both of you are finding nice ways to celebrate, without social gatherings and stuff. All right. I hope you guys eat like a really nice dinner. We did know this at the start of the year, which is why Sarah was reminded that they're twins. I think I made them hold hands or something. Okay, so let's go on to the second problem, right? So this is V, I, and R. There are 3 resistors again, so I have 1, 2, 3 total. And my resistors are 5 ohms, 25 ohms, an unknown one, and the only thing I have left is my total current, which is 6 amperes. How do I know it's my total? Because this is where the current is in one branch. It then splits, and then it comes back again. So that's my total one. Okay? We did order ourselves by birthday. Okay? All right, so from here, I also know the current going through the 25 ohm resistor is 2 amperes. And what the junction rules tells me is that if there's 6 amperes going this way, then I know that, and if 2 amperes are going this way, there's 4 amperes going this way. So the other two have 4 amperes going through them. Wow. Okay. So now I have 4 amperes going through this one and this one. That tells me the voltage here is 50. Okay, here. 2 amperes going through 25 ohms results in a 50 volt voltage drop. Okay. And here I know the voltage drop here is going to be 20 volts. Okay. Right, 20 volts here because I have 4 amperes running through there. So this is 20 volts. I know due to the loop rule, if I lose 50 here, I need to lose 50 from here to here. And if I lost 20 here, that means I lost 30 here. Right, so this is a 30 volt drop. And if it's a 30 volt drop and I have 4 amperes, then the resistance is just the voltage drop divided by the current. And that is 7.5 ohms. Right? I also know now the voltage drop is 50. Its total is 50, right? Because no matter which loop you choose, if I lose 50 here, the total voltage I lost was 50. If I choose this loop, the total voltage I lost was 50 anyway. Okay? Can you look at it as a parallel part as one node? Yes. All right. Yeah, and here I can go 50 divided by 6. Holy moly, what is that? That is 8.33, right? Ohms. The other way you could have found this, all right, is just by looking at it as a 25 ohm resistor in parallel with a 12.5 ohm resistor. Why is it 12.5? Because I have a 5 ohm thing and a 7.5 thing in series, so I combine them and I make 12.5, right? And then I can go 1 over 25 plus 1 over 12.5 is 1 over R. And this becomes 3 over 25 equals 1 over R. So R is 25 over 3, and that's equal to 8.33. So if I solve that first, then I could have gotten 50 the other way. And if you're confused about that, okay? Sorry, okay. All right, so now we can move on to the next part, right, which is okay, so we have it here. And I'm going to make my VIR chart again. Oh my goodness, though, it's getting harder, isn't it? Why is it getting harder? Because there are now 4. Nice. Okay, so I have 5 rows. let's see. I have a 70-volt battery, so which means if I ever look at this and simplify it to something with just one resistor, this is 70 volts. Well, don't I lose 70 there, right? So because I lose 70, my total drop in my simple thing is just 70. You could also look at it as no matter what path I take, whatever I lose here, I should lose 70. Whatever I lose there, and there is also 70. The total drop is 70, right? I'm going to go unknown, 10 ohms, 15 ohms, 10 ohms. Total, I have no idea, right? And I know 5 amperes is going through this guy right here. Okay, so the only thing I can solve for is simply the voltage drop due to on that one, right? So I have 50 volts here, right? I lose 50 volts. I have 5 amperes going through a 10 ohm resistor, right? What else can I solve? Well, using the loop rule, guess what? If I gain 70 there, I need to lose 70. So if I lose 50, guess how much I lose there? 20. Yummy. Okay? All right. So now where does that leave us with? I know the voltage of 2 and 3 add to 50. Like from here to here, I have to lose 50. I have no idea what that is. Okay? So I have a bit of a problem here, I think. What the heck can I do? Hmm. So from here, I'm actually very excited to show you this. There are 2 different ways you can do this, okay? A really popular way is to look at it, is to add another row, okay? And I will call this A. I saw a lot of students do this last night, actually. And A is actually 2 and 3 combined, right? I'm adding these 2 resistors combined, right? And that's a 25 ohm resistor. I know that the voltage is actually 50, right? If I have, this is RA, and now this is my 10 ohm resistor and 55 amps. That's a 50 volt drop. That means this also needs a 50 volt drop eventually, right? So if I know that, then I know the current here is actually 2 amperes. So I've successfully solved for the current going through this branch. It's 2 amperes. So I know both of these have 2 amperes running through them now. And then this is now 20 volts, and this is now 30 volts. Now that I also know that, I also know that this is 7 amperes. And the total current is 7 amperes as well. Then I know that this is 20 over 7, which is a familiar thing by now, right? I think it's 2.7, I mean 2.8, or 2.85, right? So this is 2.85 ohms. And that makes my total 10 ohms. Yeah, all right. That's the first way to do it, right? Combining and making a composite resistor here, right? That's a really popular way to do it. I was really proud that a lot of you, I saw Saeed and Cameron in particular do this, that they both showed their work that way. And you guys found that out by yourselves without me even showing you. I think that's really cool. It's creative. The other way to do that is, what did we have? This was omitted. So is this, so is this, so is this. So is this, so is this, and so is this, right? So I know you can solve this purely mathematically as well. I know that V1 plus V, whoa. I know that V2 plus V3 equals 50 volts, right? I don't know that they're 20 and 30 yet. I just know that they add to be 50. I also know that V2 equals I times 10 ohms. And I know that V3 equals I times 20 ohms. Do you see where we're going here? I have three unknowns. And this is IA, right? We can call this IA. This is the current that's going through the top branch. I'm calling it IA. You can call it V2. All right, fine. We can also call it V2 and V3. But guess what? I know that I2 equals I3. So why don't I just call them both the same I, right? That's exactly what we're doing. So I'm just going to get rid of that. So I have three equations and three unknowns. Oh my goodness. This is a standard system of equations that I can solve, right? So I know that V2 is equal to 50 volts minus V3. So I can change this equation into 50 minus V2 equals I times 10. And I have a V3. And I have V3 equals I times 20. Now what do you think I can do? I can probably just substitute this V3, right? So I have 50 minus I20 equals I times 10. And this becomes I times 30 equals 50. What the heck? What the heck? Did I do something wrong here? Excuse me. Excuse me. Oh, it's 15. This is 15. Why did I write 20? Anyway, so this is 15, and this is 25, right? And then I get I as 2 amperes. So I know the current traveling through both is 2 amperes, so I could have put those in. And then I can plug in that, right? Oh, because 10 times 2 is 20, 15 times 2 is 30, okay? All right, then after I get that, right? So I use this whole system of equations just to solve for 2 is the current. And then from there, I can solve for V2 and V3. So I've solved my system of 3 equations for my 3 variables, I, V2, and V3. And I plug all those in my chart. Then I can get my total current because I know 2 plus 5 is 7. And then from there, you can solve it out as normal, right? So that's a way for those of you who are more mathematically inclined to do this. I think this is a very elegant and beautiful way. That's my preferred way, personally. But I also really like this. Like, actually, I'm actually going to go ahead and say I don't have a preferred way. And I'll go as far as to say it just depends on my mood. If I'm feeling a bit more, if I want to flex my math skills one day, I'll just do this. If I want to like conceptualize things and combine things as one resistor and stuff, then I'll use the other method that we just did. Okay? All right. Let's move on to the harder ones. Yay. Ugh. Oh, I can't do that. Hold on, that's a drawing. Okay, I gotta get some more paper. Oh. Caitlin, when Itamar was saying the current splits evenly, I don't think he was talking about each branch getting the same current, but I think he's saying each element on the same branch receives the same current, but it would be bad wording to say it splits, right? They just experience the same current. I would never say they share or they split it, okay? For example, like these two elements receive the same current, because they're on the same branch, but I would not say they split the branch's current. All right, yeah. I would say they share it. And by sharing, I don't mean they have to split it up. They just experience the exact same current, okay? Yes, exactly, Sarah. Thank you, thank you. All right, so, wow, look at this circuit. Holy moly. There's 1, 2, 3, 4, 5. Why do you do this, Mr. So? I don't know, because I feel like some of these are fun, right? They're like real puzzles. But they're puzzles with like real life applications, right? Like these are real circuits, right? Let's go over this. So this is 1. I don't know its resistance. 2 is a 20 ohm resistor. 3 is an 8 ohm resistor. 4 is unknown. 5 is unknown. But 5 does have 1 ampere running through it. The 20 ohm resistor has 3 amperes running through it. And the total current is 6 amperes, right? This is where the current's all in one branch before it splits into 3 parts. So that means this is also getting the total current of 6 amperes. Okay? These are our givens, right? Organized on a neat chart. Wow. Okay. Only 1 cup left. Oh man. I'm gonna reheat my water first. Look how green that is, everyone. Oh. Okay. So let's start talking about how to solve this one. Right? It's almost like, it's very much like Sudoku. I like using that example because anytime I have a row that's only missing one thing, or a column that's only missing one thing, you can basically solve that missing one thing. So what can we solve for? Boom! If you look at the picture, it's clear, right? Like, oh, 3 amperes, 20 ohms, 60 volts, right? But looking at the chart, it's also just as clear. Oh, that's one row with only one thing missing, and it's 60 volts, right? So we can draw that. 60 volts here, 60 volt drop. What else do I know? Let's see. If I lose 60 here, I lose 60 here. Oh, but that doesn't tell me anything because I don't know if it's 30-30, if it's 20-40, if it's 10-50, 15-45, right? I don't know, but what do know? Oh, this guy, 60 volts, right? So there's a 60 volt drop here. And if there's a 60 volt drop and a 1 ampere current, oh, then that means that resistance is 60 ohms. Boom. Okay? Isn't that cool? Look at this, the process, right? This is like logical deduction, I think, in a way. All right? And oh my gosh, what else do I know? If this is 6 amperes and 3, that means 3 is here. And if 1 goes there, how many amperes goes there? 2. So these both get 2 amperes. I would not say they both split 2 amperes. That doesn't make any sense, right? But there's 2 amperes here. Oh my goodness. Then if there's 2 amperes going here, I do know the voltage there. This is 16 volts drop, which means if the total is 60 volts, then I know here it's 44 volts, right? And oh my gosh, now I know its resistance. This is 22 ohms. Everything's coming together. it's all coming together. Ooh. Now what? Hmm. 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 This is weird. Oh, I know my total voltage is 80, right? So why? Because my total battery is 80, right? So if I simplify this as like an 80 volt battery with just one thing, of course, my drop here is 80 volts. And that's what this row ultimately represents, right? So 80 volts. And from here, there's a lot of different ways. I can solve for my total resistance, which is 80 divided by 6, which is uh, uh, 3.33 plus What the heck? It's too early in the morning for this. 80 divided by 6. And that's 13.333. All right. So one option that you can do is make this 13.33 ohms, right? And then then I should be able to solve for this one, and that's pretty complicated, right? Because if I treat, it's basically this plus a triple parallel section. And yeah, I know this R1. So R1 plus that huge R parallel section is 13.33. And I know that parallel section, right? It's 20, 30, and 60, right? So I can do 1 over 20 plus 1 over 30 plus 1 over 60 equals 1 over R. And that R is this. And then I can solve for R1 that way. Phew! The easier way is to say, oh, if I gain 80 and if I gain 80 and I lose 60, I have to lose 20 here. Why don't I just do that? Boom, and this is now 3.33, I think. Yes, right. Which tells you that all of these combined should have been 10 ohms. So if you did that, let's see, is 1 over 20 plus 1 over 30 plus 1 over 60, is that really 1 over 10? Let's see, this will be 3 over 20 plus 2 over 30 plus 1 over 60. Oh my gosh, that's 6 over 60. That's 1 over 10. Wow, so that is, yeah, so everything does match up, right? Awesome. Gonna dry this. The ink's not dry here. If I flip it over, it'll smudge on the other page. And I'll take this time to take some questions in the chat, but also go for my 4th steeping of this pot. No questions. All right, that means we can get right onto it. All right, so let's flip this over and look at this last one. On the surface, it looks extremely difficult, right? Because there are no givens, right? I mean, there are very few givens compared to other problems, but when I say all resistors are equal, that in itself gives you a lot of givens. It almost gives you too many, I think. Okay? All resistors are identical, which means every resistor, no matter what it is, has a thingy thing of 4 ohms, a resistance of 4 ohms. So let me do this again. This is V, I, R, cool. And I have 1, 2, 3, 4, 5. All right, so 3, 4, 5 total. All right. Yes, Atune, they do have the same amount of resistance. Okay. It's been around 30 seconds. So I'm gonna pour this in here. Why do you pour it in the other pitcher, Mr. So? Because if you let it steep, if you let the water steep with the leaves too long, it gets bitter, right? So there's an optimal steeping time. So then I pour it in here, and it's ready to drink whenever I want. All right, so cool. What are they all? They're all 4 ohms. Whoa, look at this. 4, 4, 4. What are we on, a golf course? 4, 4, 4. Okay. And I know my total current is 3 amperes. And that's shared from this one and this one. So those both have 3 amperes. Okay. And I know, all right, so here's some really cool things. All right. By now, we should have seen the smaller resistance gets the bigger current. So I know when this splits into this one and this one, that this one gets more current. The more problems like these you do, the more you'll realize some other trends. Because I know that this is 4 and this is 8 ohms. This has half the resistance. It actually gets twice the current. So I know it actually splits into 2 amperes and 1 ampere. However, assuming we don't know that, right? Like we don't know that cool trick that Mr. So can do. Let's just solve out the stuff we already know. This is 12 volts. This is 12 volts, right? Now I have to look at this weird section here, right? What's going on here? Okay, so I know that, let's do it first with the system of equations. V3 plus V4 equals V5. I also know that V3 I also know that V3 is I'll call it I top, right? I top times 4, okay? And I know V4 is I top times 4. And I know V5 is I bottom times 4. All right, how many unknowns do I have? I have V3, V4, V5, I top and I bottom. I only have 4 equations. I need one more. Oh, here it is. I top plus I bottom. What is that? Brian, welcome to the stream. I'm labeling these as I would read a book. So it's top to bottom, left to right. So this is 1, 2, 3, 4, 5. But if you really want, because you're my favorite coworker, all right, I'll put them here. Okay, 1, 2, 3, 4, 5. What is I top plus I bottom? Anybody else? Right? It is 7, 8. Well, what? It's 3, right? So if I have 3 amperes going here, and it splits, whatever this is and whatever that is, it adds to 3, right? So this is 3 amperes. All right. Wait, are you really Brian Lamb? Anyways, let's keep going. So now I have this huge system of equations, and I can start solving for it. What do I want to do first? Yikes. Let's solve this one. I top equals V3 over 4. So I can change this equation to V4 equals V3. Okay, nice. So that changes this to 2V4 equals V5. Okay. And that changes, so now I have 3 equations, right? Let me just rewrite this. I have 2V4 equals V5. I have V5 equals IB times 4. And I have IT plus IB equals 3. So why don't I now get rid of IB, right? So IB is 3 minus IT. So I have 2V4 equals V5, and I also have V5 equals 3 minus IT times 4. Okay. That being said, what can I do now? Oh, this is just 2V4. 2v4 equals 3 minus it times 4. And, I'm missing something, aren't I? Hmm. 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 I should be able to solve for one variable now because I've combined all these equations. Guess who's not having a good time? This guy. Me. Oh, I see. I know that V4 is still important, right? So I know that V4 equals IT times 4. So why didn't I do that? I know that 2 times IT times 4 equals 3 minus IT times 4. All right, wow, this is 8 times IT equals 12 minus 4 IT. And I get 12 IT equals 12. So IT equals 1 ampere. Right. So from here, you can plug in everything else, right? If I know IT is 1, then IB is 2, right? So now I know IT is 1 ampere, IB is 2 amperes. If IT is 1, I know that V3 and V4 are 4 volts. And since IB is 2, I know V5 is 8 volts. You've solved for everything. You could put that in here, all right? Whew. The other simpler way of not doing this ridiculously complicated system of equations is to look at this like an 8 ohm resistor in parallel with a 4 ohm resistor, right? Yeah, you can solve the total resistance and stuff. There's so many different ways to solve this, right? And if I do this, what is 1 over 8 plus 1 over 4? This is 3 over 8. So it's 8 over 3, which is 2.67, right? So I know that this whole section is 2.67, and the total resistance is 8 plus that, which is 10.67 ohms, right? Which means my total voltage is what, 32? No. Yeah, it's 32. And if my total voltage is 32, then I know if I lose 12 and I lose 12 here, here I need to lose 8. And here I need to lose 8, right? So that's the other way to do it. You could do 8 volts here, and then you could also do, since I know the voltages are equal, why are the voltages equal? Because the currents are equal, the resistances are equal. So because I know they're equal and they add to 8, then I know they're each individually 4. All right, and then you can start solving for this. Oh, this is obviously 1 ampere, 1 ampere. This is 2 amperes. And that's exact. These numbers are the exact same that we got here, right? There's a third way to do this. There's a fourth way. I'm only going to go over those 2 ways, right? Nice. All right. And that is it for complex circuits, all right? Woo! You guys are champions. Any other questions before we go? If you are really curious to see the third method, I can do it. A third method, I can do that too. But if you're convinced that the thing is solvable and that you did it your own cool way and with the correct answers, then That's cool too. All right. Ba-bum bum, ba-bum bum. Why do you want Rocky music? I don't know. Don't you mean the happy birthday music? Happy birthday to you. Happy birthday to you. Happy birthday, dear Camara. Do you see what I did there? I combined their names, but I did it so it made the word chimera, which is itself a creature that is the combination of two other creatures. Happy birthday to you. All right. Cool. So there we go. There we have it. So today is Wednesday, right? So this is like the last day of like official school, and now our spring break. Well, starting tomorrow is a very important religious holiday, and then the week after that is spring break. So starting today, school's going to be a lot lighter. We're only allowed to give you one official assignment during this next 7-day period. The reflections that are due Friday, I'm not counting as the one. All right, so you will get an assignment sometime next week. It'll be due at the end of the week. All right, so yeah. So you have an assignment due Friday, this Friday, and then you have another assignment due next Friday, and I'll assign that Monday or something. There will still be a live stream tomorrow. It'll be going over the reflections. All right, so if you guys have any questions there, I'll be giving like a sample paragraph, okay, with how that should look like. And then Friday we will have open office hours again. I now have caster sugar, so we can make cookies. Get excited. Okay, and with that, I guess that's our plan for next week, right? It's going to be pretty fun. Yep. Have a great rest of the Wednesday. Okay.